So friends, in this video we will go through a Leetcode problem called the earliest moment when everyone become friends. Let's go through the question. So there are n people in a social group labeled from 0 to n minus 1. You are given an array logs. Okay, so logs is a double array, a two-dimensional array where every entry corresponds to this information, which is at 0th index you have a timestamp, and then what is the timestamp? What does the timestamp mean? It means that the friend represented in the first index and the friend represented by the second index in the array, at what time do they become friends? That is what this nth entry of the log information represent. And then you have this such information to the nth degree. So, and also furthermore, you have friendship is symmetric. What does it mean? Symmetric here means reflective as well as transitive, which means that if A and B are friends, if A is friend of B, then B is also friend of A. Transitive means if A is friend of B, B is friend of C, then A is friend of C. So that is the information represented here. And then what do you need to return? You need to return the earliest time where every person in the group, given in the logs two-dimensional array, at what is the earliest time when everybody becomes friends. Okay, so that's the problem. So let's go through the approach. What is the best way to solve this problem? So the best way to solve this problem is through using a data structure called UnionFind. Okay, so let me explain to you with the help of a diagram. How can UnionFind help here? First of all, what does UnionFind do? Okay, so UnionFind data structure consists of two functions primarily. One is the union and the other is the find. What does union mean? So union means that particular union function in the UnionFind data structure, it unionizes the two different groups to form a single group, right? Fundamentally, that's what union means. And then find means the find function of the UnionFind data structure, it returns the parent of a particular group where any element belongs to. So let's say if this is one group, this is another group, and there are few elements here in this group, and there are a couple of elements here in this group, right? And then you let's name them 1, 2, 3, and then 4 and 5, right? So there are two groups here. Let's say the parent of this group is 1. Okay, so this is the parent. Let's represent this group by 1, and 2 and 3 and 1 all belong to the same group whose parent is 1. 4 and 5 belong to the same group whose parent is 4. Okay, so what does it mean? Union, basically, if you tell the union algorithm or the union API to take a union of these two groups, then it will unionize them and make one of the nodes as parent of the whole group. And what does find do? When I provide find to the find API this 3 element and tell it to return me the parent of 3, where 3 belongs to which group, it will return me 1. So that is what union and find algorithms do. So let's so having this understanding of union find, let's go through an example of the problem. In the problem, we have various log statements, and you have timestamps in those log statements, and which says at what particular time A and B became friends, right? So what we will do in this problem is that every person belongs to its own group. Okay, so let's say there are 5 elements here. 1 belongs to its own group, 2 belongs to its own group, 3 belongs to its own group. You have 4 that belongs to its own group, and the same with 5. Okay, now because you want to find the earliest time when all these people become friends, you want to sort the log statements based on the timestamp. Okay, you need to do that because you need to find out the earliest time when everybody becomes friend. Okay, so after sorting the log two-dimensional log array, you start processing every entry one by one. And in each entry, let's say in the very first entry at timestamp 1, you have 1 is the friend of 2, okay? So then what you do is you make 1 is the parent of 2, like this. So you have this one group where there are 2 elements, 1 and 2, and 1 is the leader of that group, okay? In the next element, in the next log statement that you process, let's say 4 and 3 became friends. So what you do is you unionize the 2 groups 3 and 4 because they became friends, and make at random, make one of them as the leader of the group. So in this group, 4 and 3 are the friends whose leader is 3. So 4 and 3 belong to the group headed by 3. Here, let's say the leader is 1. And now we have the last group here of 5, whose leader is the self element, which is 5. In the next log statement that you process, let's say 5 and 4 are friends. Okay, so what you do here is that instead of making, okay, what you do here is you run the find algorithm in this group to find out who is the leader of this group. Okay, so you run the find algorithm on 5 and 4 both, which are the input elements. The find algorithm will return 3, and then the find algorithm on 5 will return 5, because 5, remember 5 is in its own group, so it will return 5. And so then you will unionize these 2 groups. So what you will do is you will point 5 to 3. Okay, so now we have this entire group whose leader is 3. Okay, so now we have these 2 groups, and then next entry, when you process next entry, let's say at timestamp 4, okay, at that time, what's in the next entry? The next entry says that, hey, 3 and or 5 and 2 became friends. Okay, so then you run the find algorithm. Well, you unionize the 2, and then the union algorithm will run the find algorithm to find the parent of 2, which will return 1. The find of 5 will return 3, right? And then you make the parent of 3 as 1, or the parent of 1 as 3. So then in that case, the parent of 3 is 1. Okay, so now you have the entire, all the 5 people that belong to the same group whose parent is 3. At this point, you can say that all the people which is n equals 5, they are all friends, and since you processed the earliest log that you processed at time 4, you can return that timestamp as your answer. So let's look at the code. So this is the UnionFind data structure. Here I have implemented it in Java. In the UnionFind data structure, you initialize the 2 arrays: group, which represents the group number where a particular element belongs, and rank is just a tiebreaker, or some criteria based on which you can make a decision which person will join which group. Okay, so let's continue with the construction of the UnionFind data structure. Here all I'm doing is initializing the 2 arrays, and then initializing each group with its own element as the leader, and initializing the rank as 0. And what I'm doing here is the rank basically tracks the number of elements in a group, and whichever has a greater element, that becomes the leader. I will use that criteria as the leader, as that group becoming the leader, the leader of that group becoming the leader of the merging group. So we can see that in the code. This is the find API. Let's look at find API as part of union API. Okay, so this is the main function. Okay, so which the input arguments are the log statement and the total number of people. And here I am initializing the UnionFind data structure. I'm sorting the arrays, the array logs based on the timestamp. And then here I'm keeping track of the group count, n. Okay, every time the union function does a successful merge, I reduce the group count. And when the group count becomes 1, it means that there is only one group now, which means that all the people are friends in a single group. I return that timestamp. Okay, and so basically for every log, I unionize the two arguments other than the timestamp. So the two arguments, which is friends A and B. Okay, so if the union function returns true, then I reduce the group count. If it returns false, which it will in a particular condition where both the friends belong to the same group, then you are not actually unionizing the groups. So the group count cannot go reduced by 1. It stays same. So I just skip that log and process another log entry. So let's go through one example. So these two logs, I'm processing these two logs, and what does union do? Union takes the help of the find function. It in turn calls the find API of the UnionFind data structure to find who is the current leader of a particular group. Okay, so this friend, who is the parent of that? To which group does this friend belongs? And I do the same with friend B. So which is the same as, let's say I want to merge these two groups, right? So here I'm finding, let's say 2 and 5 became friends. So I'm finding who is the to which group does 2 belong? It belongs to 1. So the find API will return 1. Here the find API will return 3, and that's how I'm merging the two, 1 and 3. So what does find API do here? If the group of that particular person is the same as the person, what does it mean? It means if I'm looking for 2, to which group does 2 belong? So I'll take group of 2. If group of 2 is same as 2, then that 2 is the owner of that group. But here in this case it's not, because 2 points to 1. So then what I do is if it's not, then I find the group of that person, right? So it's a recursive call to the same find API. So which means that what is the group of 2? 1. So then I find the group of 1. Now group of 1 is same as 1, right? So it meets this condition. So that's my exit criteria of the recursive function, and so I return person, which is 1. And after that the stack unwinding will happen for the recursive function, and I will return 1 again. So that's how I find 1. Similarly, friend B in our example is 5, right? So 5 currently belongs to 3, which means that 3 is the owner of the group, and so in the same way the find function will return 3. So I have first group as 1, second group as 3, and so they don't belong to the same group. So I will not meet this. So this I will not enter this if condition, right? And rank here is, so what I do is, if they both belong to the different groups, then I compare their ranks, and whichever's rank is higher, I make that as the owner of the group. And so otherwise, and then return true. This is how the union will return true. Let's say this condition, okay, so this condition relates to when the ranks are same. Okay, when the ranks of both the groups are same. So in that case, I just randomly assign group A equals group B. I just randomly assign, and then I make sure that I increment the rank of a particular group B. That's how I increment the count. That's how a rank basically gives the weightage, tracks the weightage of a particular group. So which also means that if I switch group A and group B here in this else loop, the program still runs. So so that's how. So what this does is, whenever there is a successful merging of the two distinct groups, only then the true will return. Otherwise, if both the groups are same, then the union function will return false, which means that every time the union function returns true, I need to decrement the group count, right? Because now the two groups were successfully merged into one. And so whenever I decrement the group count and it becomes 1, then I return that timestamp. Otherwise, I return -1, which means that there is some error condition in the input and I need to return -1, or in the end, the number of groups was not equal to 1. There were multiple groups, and which means that all the friends were never 1 in that particular log statement. So that's it. Thanks for listening. Put the comments, feedback, questions under the video. Thank you.